Hello and welcome. Today will be another exciting day of That Math Show with me, Bastian. Today I'd like to talk about a certain number. I'd like to talk about, well, a certain thing to do with numbers. It's you could call it a game that mathematicians have worked out how to do with numbers. This number I'd like to write down. Yeah, because what I'd like to work out today is this number divisible by 3? And it's not, to me anyway, it's not apparent. It's not apparent whether or not this number is divisible by 3. But luckily, there is a way to figure that out. Of course, I don't want to just tell you, because that'd be boring. If you're watching on YouTube, I guess you can just skip ahead. But if you're live, you'll have to wait for me to tell you. I'm gonna do a bit of maths, a bit of university or college maths before then. Okay. So what I'd like to do is I'd like to tell you about some well, I don't need to teach this because you already know it. The division. You already probably anyway know division, and but it's not division in the normal sense that 6 divided by 2 is 3. No, please forget that. And I will now do another type of division. It's called modulos. What it is you see what is left after dividing with some number. So I'll get to this in a bit. If you, for instance, divide 6 with 2, yeah, this, my computer will tell me, is 3. Now I want to tell you otherwise. This is not 3. This is 0. 6 divided by 2 is 0. Yeah. And how can that be? Yeah, that's a very nice question. I'm very happy someone asked that. It's because it's what's left over. So you have something. No, that's the wrong. There we are. So you have something, and you divide it up, and you see what's left over. It's division with whole numbers, and since we don't, if you divided 17 with 6, for instance, you'd get some decimal number, and I don't want to deal with that. So I'll just see what is 17 divided by 6. How many times does it fit? 6 fit into 17, and what's left over? And actually, I don't even care about how many times it divides. How many times 6 divides 17? I just want to know what's left over. I don't remember. Oh well. So 17 divided by 6. Well, 6. And you can do this the old-fashioned way, right? Because 6 plus 6 is 12, and if we add another 6, we get 18. So that doesn't work out. So there's 12, and then we take away the 12, and there's 5 left. 5 here on my hand. So I want to say that this is 5. This is too small, isn't it? Yeah. There we are. And I'll just do this, and you can actually tell what it says, hopefully. Yeah. So and if I take 6 and divide by 2, that works out 2, 4, 6. So there's nothing left over. So this makes 0. I'd like to do this again. No. Yeah. And you could do this for any number, but right now, well, we were interested in dividing with 3. So, and I will just experiment a little bit on air live. That'll go great, I'm sure. So let's say 19. No. Let's see if I remembered correctly. Yes, I did. So what this notation a little bit different because my program needs it in a special way. Normally I'd write 19 parentheses mod 3. So this means 19 modulo 3, which means 19 divided by 3 and what's left over. I'm interested in what's left over, not even how many times it divides, which is what we usually are after. What we're usually after in division. Now it's just what's left over. So if I divide 19 by 3, that's 1 left over, because 3, 6, 9, 12, 15, 18, and then 1 more for 19. Okay. I hope this makes sense, very much sense. So I'd like to do a different number. Let's just do 10. Yeah. And on such occasion it happens that 10 has the same leftover as 19. But now I well, you can actually forget this notation, and I'd like to do this. If you know something about this already, you would possibly like to write it like this. This makes sort of more sense, because it's what's left over. That's the brackets by division. When you divide by 3, there's the tiny number down here. But from now on, I will only be dividing by 3, and I don't bother writing the little number 3 down there. It's just, if I write this, it's what's left over when you divide 10 by 3. And as you just saw, that was 1. So I just want to write this. And yeah. No, never mind. I'll do it like this, yeah. And hopefully it'll be clearer what I mean. Let's do another number, just to show you sort of the point of this. That I could do. Well, it has to be some number that I actually remember. That I can divide by 3. Let's say 50. No, 50. 50 is fine. Yeah, 50 is good. This makes how shall I do this? I don't know how to do this directly. Therefore, I'll do it indirectly instead. I'll say that. Let me just use a tiny moment, to make the sizes a bit bigger. Hopefully, yeah. This is the same. I could write 50 in another way. I could write 50 like 30 plus 20. This is pure maths. It's not black magic. It's just, 50 and 30 plus 20. That's exactly the same. And and I'd like to write this in another way, just to make it difficult. 30 plus 10 plus 10. And now there will be a slight jump, because this next bit I'm going to use, I don't bother proving that, because never mind that. It's a little bit long and difficult, but the matter of fact is that it's true. You can do this. Whoops. I can write 30, and you may not realize what I'm doing here. But it's not apparent that these are similar. I don't know. They actually turn out to be, but if you're a mathematician, you might not accept this just because I'm saying it. But I think you'll have to prove this on your own time if you bother. If not, you'll have to stick with that I'm saying it, and that makes it true. And what's nice about this is that this is easy to figure out. Because I know if I divide 30 by 3, I know that 30 divided by 3 is 0. Well, 30 modulo 3 is 0. That's what I mean. So this is 0 plus, and what's left over if we divide 10 by 3? Well, 3, 6, 9, and 1 left over. So this is 1 plus another 1. we just figured this out, that 10 modulo 3 is 1. So yeah, this makes 2, of course. So if you take 50 divided by 3, there's 2 left over. And we can check this, because, well, of course 10 times 3 is 30, so 30 is divisible by 3. And then there's 30, 33, 36, 39, 42, 45, 48, and then there's 2 left over up to 50. And we can't do another 3 within the 2, because 2 doesn't, that doesn't work. Yeah, I guess I should note that the brackets of 2, when I'm taking 2 modulo 3, that's just 2. Plain and simple. If you divide, you can't divide 2 with 3 any times, and then there's 2 leftovers. That's all there is to it. Yeah, and so what about this number? Well, I guess we could do the same, but there is a smarter way. Yeah, I'd like to. Well, no, I'd actually want to do sort of the same. Yeah, sort of the same. I'd like to write it in brackets, so I'll just go ahead and do that. 36. Yeah, and what is that? Well, there's a bunch of. I could add this together in many different ways. Of course, I could. Yeah, 17,000 plus 506, 17,000 plus 500 plus 6. There's a bunch of ways to do this. Although there's one that I like to use, because this will, this will be practical later, and it's just one of them. No, I need to do this. Yeah, I'd like to do 1. No, what? This is not. Here we are. 1 times 10,000. Yes, 10,000. 4. Plus. What am I even doing? Times 1,000. Yeah. Plus 5 times 100. Times 100. Plus. And then I don't need to make any 10s. 0 times 10. And then 6. Yeah. Plus 6. Yeah, so hopefully we can agree that these two numbers are the same. They might not look like it, but what I've done is just to take each digit, they are over there, and take each digit and multiply it so it goes in the right spot in the number. I've multiplied it with 10,000, so this makes 10,000, and then this makes 7,000. Yeah, it does. Please, if I make any mistakes, please tell me, because I might very well make some mistakes. Just writing mistakes. Not, I won't make math mistakes. No. Yeah, and then 5 times 100, that makes the 500, and then we add another 6, and then it's the whole number. Yeah. So yeah, and I just told you can do this interesting thing of doing the brackets, writing out the brackets for themselves. So they'll be, and I'll just be lazy and skip this one, because that doesn't matter too much. 10,000 plus 7 times 1,000 plus 5 times 100 plus 6. Oops. Yeah, how very nice. This is clearly much easier to figure out. Well, it's not really, but if we just keep going a little bit, it'll be much better in the end. Yeah, what would I like to do now? Well, I'd like to, these multiplications, I'd like to write them out as well. And again, I can do that. It's not obvious that I can, but I actually can. And yeah. You can go ahead and ask me, but that will be a longer video, so I'm not going to do it right now. Yeah. Now we are clearly much closer. Well, there's some things we can tell about this already. Yeah. This is nice about writing this down on computer, actually. There's 6. If I divide 6... No, that's not what I want to say. It's too bad I don't have a tenner, cause, but I could do something different. I could do... Oh, this has to be a multiplication sign. Yeah. I can write 100 as 10 times 10, and then I do the same thing of splitting it up. And this is nice, because we know... I've told you already what the rest of 10 is when you divide by 3. Oh, this is the wrong one. Oh god, this is going to be a lot here. That one, that one, that one. That one, that one, that one. Yeah, here we are. Now it looks very long and complicated, but I want to say that it's actually easier now, because we know what the rest of 10 is, and we know what the rest of... Well, we don't know what the rest of 7 is, but because we know what the rest of 10 is, it's very easy to figure out what the rest of 10,000 is, or the rest of 100, or any multiplication of 10. Because, well, 10, the rest of 10 by if you divide by 3, 10 modulo 3 is just 1. So that's very simple. And all this is 1. No, I'll write it out actually. Oh. There's not quite enough space here on the screen, but yeah, it'll just get longer downwards. That's okay. And all these become just 1, 1, 1, 1, 1. No, this is not what I want to do. No, never mind. This becomes 1 times 1 times 1 times 1 times 1 times 1 plus, and then we need the rest of 7. 3, 6, and then another 1 to 7. So that's 1 times 1 times 1 times 1. 1, 2, 3, 4. 1, 2, 3, 4. Yeah. And then we need to add 5 times 1 times 1, and then we have to add... Oh wait, I did 5. I don't need to do 5. I can make it down to an easy number, because what's 5 modulo 3? Well, that's just 2. Yeah, that shouldn't be black magic to you anymore, hopefully. And this 6 becomes a 0. Yeah, because 6 is divisible by 3. Yeah. So no, I don't need a program to figure out this number for me. I can do that in my head. Well, 1 times 1 times 1 times, that's 1. This is 1 as well, and this makes 2. Yeah. That's... Come on. Yeah, there we are. So I have 1 plus 1. Yeah, and this is where my notation fails me actually. Plus 2. I'd like to put brackets around this. And this will take a little bit of time, but I'd like to put brackets around all these. And I have made a mistake. Whoops. Which I'm fixing hereby. Yeah. But well, if you divide 10, so yeah, I've just put brackets around the numbers. It's really the same, because remember I did 2, the brackets around 2, that's just 2, so it's the same. And if you divide 10 by 3, you get 1. If you divide 1 by 3, you get 1. So these two are the same. If you divide 5 by 2, you get 2, so that's if you divide 5 modulo 3 is 2 and 2 modulo 3 is 2. I've pretty much stated. Yeah. So this is the same as 4 modulo 3. Brackets around 4. And this is the same as 1 modulo 3. Well, 4 modulo 3 is 1. So when you divide this number by 3, what's left over? It's the same here as here, as here, as here, as here, as here, and as here, as here, and it's 1. So if you divide this number by 3, you get 1 left over. So this number is not divisible by 3. Well, yeah, I promised an easy way to do this. I guess this is not, but well, what's important to notice here is that if we had skipped the 10s, we would have gotten the same result. Yeah, because all the 10s were just multiplications of 1, and that doesn't matter. That doesn't matter at all. Yeah. Actually, what I think I'd like to do is add something here, and hopefully that'll make the world clearer. Now I'm doing the 1 again. I can't really decide if I want it there or not. Plus the 5. Yeah, this is the important point. That all these 10s, because they are all 1, as I already said, and as you hopefully heard and got understood, they are all 1. So I can just skip them and write the numbers. So this is the entire number, and this is the digit sum of the number. You can see this is 1 plus 7 plus 5 plus 6. That's the digit sum of the number. I hope you're familiar with the digit sum, because that's really important. Well, digit sum, yeah, that's just the digits of a number added together. So 1 plus 7 plus 5 plus 0 plus 6. Yeah, yeah. Yeah, and I can prove this generally. This will be, I will try and make this as much like I do on university, as possible. Yeah. So take a number A. I don't like that there's 2 A's. Yeah, let's do, but never mind. And we shall write it. I'll write it. Yeah. Now, I have not prepared this. This is not from memory. This is from thought, because that's the thing. That's the sort of thing you learn on college in maths, and it's fun, and it's well, it empowers your brain. And the digits I will call A1. Oh, A1. Oh, wait a minute. A1, A2, and all the way up to A. Oh no, this is the wrong one. AN. Yeah. So I have a general number. I don't know what number it is. If you are confused by this, just pretend like it's this number, or you can make up your own number, and it'll hopefully make sense. I guess it should. Oh, well, then you won't be able to see it. I'll just write it over here. 17506. That's not quite the right color of blue, but that'd do. Yeah. The thing is, though, as a mathematical thing, you'd argue that I know that it's a finite number, and therefore there is a last digit. It has n digits. This number has 5 digits. This number has n digits. And that's not a problem, though. And I'll try and keep going. Yeah. No, what am I doing? Right. Yeah, so this is where this is the first digit, this is the second digit, and then the third and the fourth and the nth digit. So I'll do yeah, a n times 10 to the power n plus this I'm imagining this to be horribly confusing, but well, that's the way we do it in maths. 10 to the power n minus 1, and then I add stuff. No, wait a minute, I have to add stuff to make this pretty. I'll just I'll have to yeah, I'll do it strangely, whatever. Plus, and then comes a2 times 10 to the power 2, which is just 100, so no biggie there. A1. No, I've made a mistake, haven't I? Yeah, I have, because the last digit of a will not be times 10. The last digit of a will be times 1. Yeah, 10 to the power 0. Yeah, because you know there might be a last digit. So I'll just add another digit, and it'll be fine. A times 10 and a 0. Yeah, and of course there's something in between here. Yeah. My mathematics program is being sort of annoying, but this is how you write a. So it's what I've done up here. I took the biggest power of 10, which is 10 to the 5th in this case, and wrote it out here, 10,000, and I multiplied it with 1, the front number. Then I did the same for 7 times 1000 and 5 times 100, and I didn't bother with the 0 because 0 times 100 times 10 is just 0, and we don't care about that. But here I can't be sure, so I have to write all of them out. And you have to imagine that if you pick a number, I will write it out like this, and I can do this for any number at all, any whole number. Yeah, because this whole number division doesn't work out too great with commas and non-whole numbers. Yeah. What I'd like to prove is then I'll write this with brackets. Yeah, I'll, so to speak, divide it by 3 and see what's left over. Yeah, but then I know I can do that whole splitting, putting the brackets in other places if I want to, so I'll do that. And I will well, actually, I'll put a few more brackets in. I'll put them in like this. So each number gets its own bracket, and I would do this. Oh, I would do this for all the n well, n minus 4, n minus 5 numbers in here, but yeah, since I don't know how big n is, I just write it like this, and hopefully you'll get that that's what I mean. Yeah, this is the biggest number, this is the second biggest number, yeah, and what I then know is, oh yeah, this, I could write this with sum. This yeah, mathematics is a language, I may have said that before, and this could be written as the sum from n equals 0 up, no, from I equals 0 up to j. This has nothing to do with the complex I of the square root of minus 1 of ai, what I like to, times 10 to the power I. Yeah, what a this is the line up here is this, and if I just if I just do the brackets, no, damn it, oh well, this doesn't do as I want. And then the second thing I wrote is this. You may or may not understand this, but it looks clever, and that's what really matters. Yeah, I'll just delete this. So what this says the sum of a0 times 10 to the power 0, so that's just 1, which is this number, and then there's a, oh no, this has to be an n, doesn't it? Yeah, and then, well, it's just the sum. It's just a clever way of writing the same thing. Yeah, but I won't bother more with that. No worries. Because I'd like to work on this, and what I know is that I could write this as 10 times 10 times 10 times 10 times 10, and then I could put the brackets inside, and they'd all give me 1. So I can write in a much easier way. No, it doesn't want to. Oh well. 'Cause I could just write. I did not do the brackets properly here, as you can tell. This has to be in its own bracket. This has to be, this sign is the wrong, oh no, that's God. This is not going all too fantastically, but I would like something here, something there, yeah. And I'd like something there, and not something there. Yeah, there we are. What is this? There we are. Doesn't look as pretty anymore, but this is the important bit. This is the important bit. So this is just the sum. Well, they are all multiplied with 1. So this is just the sum of an plus an minus 1 all the way down to a2 plus a1 plus a0. So, and these are the digits, so I just add the digits together. And what will these digits give me? Well, they'll give me the digit sum, yeah. And I will now do the brackets back, so I'll get an plus an minus 1 plus a2 plus a1 plus a0. And of course I have to remember all the ones in between, because I don't know how big n is. This is where they go. Yeah. So this is the digit sum, and what this tells you is that the digit no, this isn't the number I started with, exactly that number. What's left over from this number when you divide by 3, I really want to write this. This is what's left over when you divide a by 3. That's the same as a is the same as this number, so I just exchange that. Then I do a few more. I do the brackets in and out, and write it funny mathematically. No need for that really, but it's jazz. And then I end up with that the digit sum has the same rest with the same left over. It's the same value modulo 3. If you divide by 3, there'll be the same left. That's the important bit. So instead of doing all this, I have now proved that if we wanted to do this number, we could just have started out easy. If you have wanted to find out if this number was divisible by 3, all we'd have to do is add the digits together and check out if they are divisible by 3. So I don't even need to write this out. I could do this in my head. Well, I guess I'll write it out anyway. But this will be 1 plus 7 plus 5 plus 6, which is 12, 19. Yeah, is 19 divisible by 3? Nope, it's not. It's there'll be 1 left over. So this will make something 0.333333 recurring. Oh, I guess I'm showing the wrong way. Yeah. Oh well. Deal with it, please. Yeah. So if you ever have some amount of I don't know, cakes, cookies, something you want to split between 3 people, money. Well, let's just go there. You can make sure that you have the right amount of money to divide. You can make sure that it's divisible by 3 by doing this method, adding the digits together and divide that with 3 and see if that works out. And if it doesn't work out, well, this I don't know how to write this, but I'll do something forbidden. Yeah, this is the same as 1. It of course isn't, but the rest of it is actually the same. Yeah, so but what I now know is if I add 1 to this number, it'll be the same as 2 divided by 3. Yeah, I have actually proven that. This is the proper mathematical way of doing it, as you do in university. If I add 1 to this will make 20, and it still won't be divisible by 3, but it'll have there'll be 2 left over if I divide by 3. So if I just add 1 more, so that's 2 added to 19, it'll make 21, and 21 is divisible by 3, because 2 plus 1 is 3. Yeah, so there you go. 21 is divisible by 3. So what I need to do what I've done is I have made the digit sum 2 bigger. So if I add 2 to any of these digits, it'll be divisible by 3. So if I add 2 to 6, that'll make it 8. This will now be an 8. It should hopefully make 21. I can't. Yeah, it does. This makes 21, and it's divisible by 3. It's the same as 0. Well, it's congruent to 0 modulo 3, to be proper precise. Yeah, and there you go. If you have any cookies, you might have to add a few or take a few away, because just before, if we had taken 1 away, it would have worked out just as nicely. So this was the original number, which made 19, which was the same as 1 when you divide by 3. I have to emphasize that this that I have written on the screen is not true and strictly forbidden. But hopefully you'll understand what I mean and won't kill me for it. This is one, so if I just had taken one cookie away, if I had eaten one of them myself, oh, well, that's taking 6 away, that's a bit much. If I'd taken one of them away, this would have become 1 lower, this would have become 1 lower, and this would have become 1 lower. That's what I've proven here with all these signs and n's and a's and letters and stuff, which is the proper way to do maths, just in case you're in doubt. Yeah, and they will split perfectly. Of course, if things always split perfectly when you are the one sharing the cookies, your friends might get suspicious, but it's just lucky. Yeah. Thank you for watching today. Bye.